Okay, so if there's any extra pages, let me know and I'll take them back up. But we are going to get started with 6.1. I did get the entire unit printed together this time instead of us having separate pieces. So thankfully, that is taken care of now. So we're going to go ahead and we're going to look at 6.1, exponent rules. Okay, so we're going to start just by kind of talking about what we're looking for when we're looking at exponents. So whenever we have an exponent, we have the exponent and we have the base. Okay, the base is what is being raised to that power. So in this case, our base is x. Okay, and then the exponent is what it is being raised to. And you can also refer to an exponent as a power. And that should be done in just a second, hopefully. So the first thing I want us to look at, okay, is I'm going to write a couple things up here that you do not have to write, that I'm just putting up here so we can kind of reference it as we go and kind of get some understanding of what's going on. Okay, so there is something I do not want today to be confused with. Okay, so if I gave you this right here, 2x squared plus 3x, can I combine those two things?
No.
Why can I not? They don't have the same exponent. They are not like terms, okay? X squared and x are not the same. We cannot add those together. We also can't subtract them together. If they are not the same base and the same exponent, we cannot add them together. Does that make sense? Okay. Now, what we are doing today is we are looking at things that apply directly to the exponents. Like when we multiply things, when we raise powers to powers, when we divide things with exponents, that is what we're going to look at. We are not going to be looking at it as the adding and subtracting type situation, okay? So our first thing that we're going to look at is a product of powers, okay, or multiplying powers. So the example we're going to look at first is if I give us x to the third times x squared. I couldn't add those together, but I can multiply them together. What do you do when you multiply two things? What do you do with their exponents? Add them. So that would be x to the fifth, okay? That is our first set of problems. And that is what that rule is. A to the power m times a to the power n is equal to a to the m plus n, right? You just add the exponents when you multiply two things together, okay? They have to have the same bases for us to do that, okay? Could I multiply x times y and add the exponents? No, because the bases aren't matching. It would just be xy. Here, though, we have an a and an a. Let me answer this and then we will. Hello, this is Miss Williams. I'm good. How are you? Yes, yes, ma'am. Yes, ma'am. Ellie, they need you in portable 912. Okay. So. Oh, yeah, that's almost done. Thank goodness. All right. So let's look at the examples here. So for the first example, we have 3 to the 4th power times 3 to the negative 1 power. So we're going to say 3 to the 4th plus negative 1. What is 4 plus negative 1?
3.
So we should have 3 to the 3rd power. What is 3 to the 3rd power?
27.
27. Okay? Because 3 times 3 is 9, times 3 again is 27. All right, now, we have our next example. X to the 3rd times x to the 5th. So for this one, we have x to the 3 plus 5. So what do we get? X to the 8th. Yes? Mm-hmm. Okay, now one thing, you do not have to write out this step when you do these. Okay? That is just if you need it, do it, okay? If you don't need it, that's okay with me. Just make sure you know what you're doing. I would recommend at least on the examples to do that. All right, for our third example, okay? This one here, we have a constant of 2 in front of the first one, right? For the second one, what is the understood constant to be right here? I mentioned that because whenever these have constants, what we need to do is we need to deal with the constants with the constants. The x's with the x's, the y's with the y's, right? So what is 2 times 1? 2. Okay, then for x, what is the exponent on this x? 1. Okay, if it does not have an exponent, it is understood to be a 1. So that would be 1 plus, what's the exponent over here? So 1 plus 2. And then for y, it would be 3 plus 1. Yep. So we get 2x to the y to the 4th. All right. So what I want y'all to do is I want y'all to do examples 1 and 2 real quick. Over there in the first aid drawer. All right, what did y'all get for number 1? X to the 6th. So we would do 2 plus 4, which gives us 6. So we get x to the 6th. All right, what did y'all get for number 2? Yep, x to the 4th, y to the 9th. Okay, this first x has an exponent of 1. So we would do x to the 1 plus 3, which gives us 4. Then x to the 2 plus 7, which gives us 9. All right, now we're going to look at raising a power to a power. Okay, so I want to talk about this part. So when it says raising a power to a power, okay, or power of a power, what that means is we are taking something and we are raising it to another power, okay? If I was doing this, does anybody remember what I need to do with the exponents here? So 2 times 3 is 6. Okay, one thing that's important about this is recognizing when or when not something is included in the power. So if I have 2x squared, is the 2 being squared, is the 2 on the outside being, is the 3 being squared? No. Why not? Because it's not outside the parentheses, okay? What if it was like this? Then is it being squared? Yes. So we have to make sure to include that when we have it, okay? So for this one, our rule is if you have a times b raised to the power of m. Oh, that's the wrong one. If you have a to the m raised to the power of n, then you multiply your exponents together, okay? So let's look at this first example. So here we have 4 to the power of 2 raised to the power of 3. So I need to do what with those exponents? What is 2 times 3? So 4 to the, somebody with a calculator, tell me what 4 to the 6 is. 4,096. If it's a number you can write like that, yes. Okay. If we can write it as a number, yes. If we can't, then don't. Okay. Now, for the next one, we have x to the 3rd to the 3rd. So what do I need to do with those exponents? What is 3 times 3? So we have x to the 9. All right. Now for the last one here, we have 2x to the 4th squared. Is the 2 being squared too? Okay. So we have 2 squared, and then we have x to the 4th squared. Okay. What is 2 squared? And if I multiply those exponents together, I'm going to get x to the, all right. And we're going to go ahead and do power of a product as well. Okay, power of a product. So here, do you see how we had to evaluate the 2 as well for this one? Okay. That's all it means to be a power of a product. If you have 2 things that are multiplied together, you have to take that power and go to both of them, just like we did here. Because when we square something, we're multiplying it by itself 2 times, right? So if we have xy squared, that is the same thing as us doing xy times xy. What is x times x? X squared. What is y times y? Y squared. So we have to make sure that square goes to both of the things being multiplied together there. Okay? And that's what the power of a product is all about. Okay? So if we start with this first one here, we have 2 squared times 3 squared. What is 2 squared? 3 squared? 4 times 9. Which we could double check that. What is 2 times 3? 6 squared is? There we go. Okay, now for the next one, we have x times y squared. So what do I need to do to both of these things? So we have x. What's the understood power on that x? So it would be 1 times 2, which is, and then the y would be the same thing. So 1 times 2, which is 2. Now we have this one here, okay? So both 2, x, and y all need to be raised to what power? Okay, so it will be 2 to the x to the y to the, and what is 2 to the third? So it would be 8, x to the 6th, y to the third. And we would get that by multiplying 2 times 3 and 1 times 3. Okay, I want you to do 3, 4, 5, and 6. Those kind of go together, which is why we're doing them together. Yes? The 2 in front of the x. So we're raising it to the power of 3. So it is saying 2 times 2 times 2. So because it is inside this parentheses right here, it is one of the things we have to cube. So what's actually happened is here we have 2x squared y times 2x squared y times 2x squared y. What is 2 times 2 times 2? 8. So that's where we get that from, okay? And so us just writing it as cubed is just a shorter way to write it than writing out this whole thing, okay? Then we would have x squared times x squared times x squared. So 2 plus 2 plus 2 would give us 6, so x to the 6th. And then we have y times y times y, which would give us y to the third. But that's what's happening there. Does that help? Okay. So I want y'all to do 3, 4, 5, and 6 if you haven't already. I'll give y'all just a second. All right, what did y'all get for number 3? For number 3? X to the 12th, yep. All right, what about for number 4? What did y'all get for number 4? 4x to the 10th. Why is it 4x to the 10th for number 4? Okay, because that 2 is inside the parentheses, so we have to square it. So 2 times 2 is 4. Okay. What do you mean they're not on your paper?
I don't think so. Do we not already do this? No.
No? It's definitely on there.
I'm sure there was a Then why am I already? Then why am I Gotcha. Okay, continue.
All right, now we're going to talk about the zero exponent rule, okay? So while we're looking at this, okay, I want to to understand this, we kind of have to have a general understanding of exponents in general, okay? So if I have 5 to the first power, what is that? Okay, if I have 5 to the second power, what is that? If I have 5 to the third power, what would that be? And that would keep going forever, right? So what is happening between here and here? It's getting multiplied by 5. What about from here to here? So if I was to take this back to 5 to the 0 power, what number would you multiply by 5 to get 5? 1. Okay? 5 to the 0 power is 1. Because you aren't multiplying it by 5 any times, right? But if it was 0, what is 5 times 0? 0. So could that get you to this next step? No. It has to be kind of like and it works with 1 because it doesn't matter what I change the base to. It could be 1,000. Can I make 1 into 1,000? By multiplying it by 1,000. Okay? So that is why the zero exponent rule works, is because it takes what's the one number that you can turn into any number by multiplying it by itself, and that's 1. Okay? So for our zero exponent rule, we have 5 to the 0, which is 1. 5x to the 0 power, which is 1,000x to the 5th to the 0 power, which is 4x to the 0 power, which is 2x squared y to the 0 power is, all right. I love those. Those are great. Okay. All right. Now, we are going to look at quotients of powers. So when you multiply two things with exponents together, you add the exponents. So when you divide, you should subtract the exponents. And that is what we're going to do here. So for this one, we have 4 to the 3 minus 2. What is 3 minus 2?
1.
So we have 4 to the first power, or just 4. Okay? Why this works, okay? When we raise something to the third power, how many times am I multiplying it by itself? So it would be 4 times 4 times 4. And in the denominator, we would have 4 times 4. So if I wanted to simplify that, I can simplify it by dividing out 4s, right? So 4 divided by 4 is 1, so that makes that cancel out. 4 divided by 4 is 1, so that makes that cancel out, leaving just what? 4. And so that is why the subtraction things works. You're dividing out the pairs of things in the numerator and the denominator to leave you with just the things left. Okay? But that is why that works. So if we look at this next one, okay, in the front of this one, we have 2 constants. Okay? The constants, we let them do their thing. So 4 divided by 2. Then we're going to have x to the 5th minus negative 2. What is 4 divided by 2? Okay, now, when you subtract a negative number, you. So what is that going to be? X to the 7th. 2x to the 7th. Because when you subtract a negative number, you add. Okay, now for this one. Again, we have our constants in the very front, so we're going to let them do their thing. 3 over 9, x to the 7 minus 3. So what can I simplify 3 over 9 to? Then it'll be x to the... Now, I could write it like this, or I could write it like x to the 4th divided by 3. Either way works. Okay? Because since this is a positive exponent, it goes in the numerator. Yeah, you take care of the constants together, and then you do the x's together, y's together, whatever. Okay? Now, I want you to go ahead and do 9 and 10 for me. For for number 9, what did you get? Okay, because we do 4 divided by 2, which gives us 2, and then we have x to the 4 minus 2, which gives us x squared, so 2x squared. What did y'all get for number 10? 1/2 x to the 8th power, okay? Because 3/6 simplifies to 1/2, and then 6 minus negative 2 is 6 plus 2, which is 8. All right. Now, we have power of a quotient. So, real fast, let's recap something, okay? So, if I have x squared y to the 3rd, all of that raised to the 5th power, okay? What would my x exponents be?
10.
And then what would y be?
15.
Okay? If I was to rewrite this, instead of multiplying right here, and I set it up as dividing, okay? And I still raised it to the 5th power. That same idea has to hold, okay? Both things still have to be raised to the power of 5. So we would get x to the 10th divided by y to the 15th. The only thing that changes is that instead of multiplying right here, we're dividing. It goes to both. Because whenever we're dividing, we could rewrite that as x to the 5th times 1 over y to the 3rd. Raise it like that. We can write any fraction problem as a multiplication. It's the same thing. Okay? And so that is why we can do that. Okay? So for that section, okay, it's power of a quotient. So let's go ahead and look at the first one. Okay? We have 2 to the 4th power over 3 to the 4th power. What is 2 to the 4th power? 16, because 2 times 2 is 4, times 2 is 8, times 2 again is 16. Okay? 3 to the 4th power? 81. Okay? Then we can look at the next one. Okay? For the next one, both of these things have to get raised to the power of 3. So we're going to have 3 to the power of 3. And then we have 2 to the power, x squared to the power of 3. What would that end up with? X to the what? Over what? X to the power of 3. Now, what is 3 to the 3rd power? Okay, what can I do with these two since they're both x's? Subtract our exponents to get x to the 3rd, because 6 minus 3 is 3. All right, then we're going to look at this next problem. Okay, for our next problem here, we're going to get x to the what? Over y to the... Can I simplify those two like I just did the one before it? Why not? They do not have the same base. They do not have the same variable right there. Okay, now, the last one we're going to look at is negative exponents. All right, so negative exponents are the ones that tend to give people the most trouble. Okay, so I want us to take a second and we're going to talk about it before we do it. So for negative exponents, we're going to go back to this example right here. okay? So we've already done this part, right? So we're going to go back the other way just a little bit. So if I did 5 to the negative 1, we have to figure out what we can multiply by to get 1. So if we do 5 to the negative 1, what do we get? Not negative 5. 1/5. Yep, it is 1 over 5. Okay? If we did 5 to the negative 2, do you know what we would get? 1 over 25. So all it is doing is it is taking it and flipping it to the denominator. The negative exponent does not make it negative. It just flips it to the other side of the fraction. Okay? So if I had 2 to the 0 power, 2 to the first power, and 2 to the second power, what is 2 to the 0 power? What is 2 to the first power? 2 to the second power? And that would go on forever. So if I do 2 to the negative 1, all it does is make it 1 over 2. If I had 2 to the negative 2 power, it would be 1 over 2 squared. What is 2 squared? Okay, that's all it's happening is it's sending it to the other side of the fraction. Do what? Okay. Now, sometimes those things are in the denominator. Okay? So we already know that 2 to the negative 1 is 1/2. Okay? So if I have the equation 1 over 2 to the negative 1, what did we just get finished saying that 2 to the negative 1 is? So it's 1 divided by 1/2. When you divide by a fraction, what do you do? So we have 1 times, what's the reciprocal of 1/2? Which gives us what? So this took it from the denominator to the numerator. So all it does is it take it and flips it around the fraction when you have a negative exponent. So let's do one more practice of this before we look at our paper. So if we have a to the negative 2 b squared over c to the negative 3 d. Okay? Where would the a need to move to? Okay? And when it moves down here, it's going to become a square. It's going to become positive square because it's moving. The negative moves it. The exponent stays the same. The negative just moves it. Okay? Do I need to move b squared? Okay, it can stay up where it's at. Okay, c to the negative 3. That needs to move where? And when it moves to the top, it'll become to the positive 3. And then does the d need to move? There we go. Okay, that is all that's happening. When it's negative in the numerator, it brings it to the denominator and makes it positive. If it's negative in the denominator, it brings it to the numerator and makes it positive. That is all that's happening. Okay, so for the negative exponent section, let's do these questions. So for this one here, is 2 being raised to the power of negative 3? No. Okay, it is not in parentheses, so it is not being raised to the power of negative 3. Okay, so will 2 stay in the numerator or the denominator? Okay, where would I put x to the negative 3? And it needs to become x to the positive 3. All right, then we have our next question where we have 1 over x to the negative 2. Okay, so for this one, is there anything in the numerator that we need to worry about? No. Okay, but in the denominator, what do we have? So where does that need to move to? And when we move it to the top, it needs to become? Okay, we can either write it like that, or we can put it over 1. Okay, because technically, that is what's in front of that down there. All right, now, the third question, okay? Everything here is being raised to what power? So I'm going to deal with that first. Okay? So we're going to get x to what power? Divided by y to what power? What is negative 4 times negative 2? Negative 4 times negative 2. 8. Positive 8. Okay, now, does the x need to move? Where? To the bottom. Does the y need to move? Okay, now, this has to stay a fraction, so we're going to leave the top as 1. Because what's understood to be in front of this x? But that is all that you're doing with negative exponents, is you're just moving them to one side or the other of the fraction. Okay? So I want you to go ahead and do 13 and 14. What did y'all get for your answer for 13? Have you got it yet? What is it? Not quite. 1 over 16x squared. Okay? Because both of these have an exponent of negative 2. Right? So they both go to the denominator. So we get 1 over 4 squared, x squared. What is 4 squared? So 16, x squared. Okay? Because both of them get the power of negative 2. Then for 14, we're going to start by making sure everything gets the powers they're supposed to. So x is going to have a power of what? Y is going to have a power of. So where does that mean the x needs to move to? And so we get x to the x squared. And then in the numerator, we're going to have y to the 4th. And can I simplify that any further? All right. So that is our exponent rules. Okay. So what we're going to do is we have an assignment on Delta Math. Okay. Exponent rules are one of those things in math that's kind of like muscle memory. The more you do it, the better the skill gets. So in Delta Math, we're going to do it because it lets you automatically know if you're right or wrong. Okay. And we spend less time doing things incorrectly. Okay. In Delta Math, to write an exponent, you do shift 6. Okay. It will send it up to the top so you can write an exponent. Okay. Shift 6. Okay. If you have questions, let me know. I spaced it out by the different types, and then at the bottom I just did mixed practice.
Is the other one on Friday still open?
It is, yes. Yep. Okay. Listen, for Delta Maths in general, I went in and I hid all of the Delta Maths from the previous 2 quarters. Okay. So the only Delta Maths you can see are the ones we have done this quarter. Okay. I have left them all open. Okay. You can go back in and do any of them for full credit. Okay. Making sure they get done.